welcome to day 2 of the RCCS machine learning course TensorLab'. So if you don't know, I'm Sanderu Arya Singha. And so today we are going to learn about something called learning strategy and another subtopic called linear regression. That's a really big word, I know. But once you learn it, you'll understand it's a pretty simple concept. But I need everybody's attention. Malay, listen. Now, recap. Last session, what did we do? Can anyone remember? Machine learning. Can anyone tell me, now AI, we know, what's the analogy we use for machine learning? We talked about 3 boxes, right?
Yeah.
What is it? Okay. Yeah. So in traditional computing, Mali, are there any people who didn't watch the recording of last day? Who didn't come last day and also didn't watch the recording? Okay. You will have to go home today and watch the recording, huh? Right. Can you hear me now? No. Now it's fixed, I think, Mali. Okay. Okay, good. Now, are you familiar with this? Yeah. People who were there last time, are you familiar with this?
Yeah.
Okay. So, in traditional computing, we give the input, we give the, we give the input. In traditional computing, we give the input and then we give the output, the process also, right? We want to get the output, right? Machine learning, we give the input and the output. We want the process, right? Clear? Okay. You can come. Yeah. Now, learning strategy. Learning strategy means now we learnt about machine learning, right? So we talked about teaching computers. But there are different ways to teach computers, okay? Now there are different ways you guys learn as well, right? So there are basically 3 ways. Basically, okay? One is called supervised learning. The other is called unsupervised learning. And the third one is called reinforcement learning. Okay, don't get bored. Do you know the meaning of the word supervised? Okay, supervised. Unsupervised means the opposite of that.
Yeah.
Reinforcement?
It's like getting some help.
Okay. Let's see. Just write these down if you want. We'll see what they mean. Now, supervised learning. In supervised learning, what we do is basically what you learned last day. We give input, we give the output as well. And we ask for the process, right? And ask for the relationship. But now, last day we discussed there are as 2 ways, right? Now, first is we discussed about series. Do you remember? Like number patterns?
Yeah.
Okay. It was like we give some numbers of a number pattern, the first few numbers of a number pattern, and then we asked what are the next numbers, right? And the other thing, we also did some classification problem. Do you remember that? Dog and cat, right? No, that is not a pattern, right? That's basically categorizing, right? Good, right? That's what this is basically used for. Basically what you learnt in the first day, that's all. Okay? Supervised learning is what you learnt on first day. Got it? So it's basically used for regression and classification. Regression means predicting the next value in a trend, or else predicting the next value in a number pattern, in a series, in a sequence of things. Okay? Now let's say, last time you remember the odd number pattern, right? We give the first few odd numbers and we tell what's the next odd number. We asked, right? And that was the types of learning. We'll go through them. You'll get them. Huh? So regression also is used in places like, now let's say, have you guys heard of the stock market? Have you seen that graph going up and down and up and down? We can use AI to predict whether it will go up or down. Okay? We can use AI to tell what the pattern is, and then we can exploit it and earn money. Okay? We can predict the future and earn money. Something like that. So that's basically a trend, right? Pattern, a series, right? A number pattern, a fluctuation, something like that. So we can predict what happens next. And the other one is classification. That's very familiar, right? Dog or cat classification, male or female classification, voice classification, identifying your voice. Have you used Siri? Have you noticed that when it answers only when the owner of the device speaks? For example, the Siri on my device. Okay, I don't think. See, that's like a classification as well. Okay, and face classification. Okay. So those are the two main categories. Regression. Do you remember regression in the title? Today's topic, linear regression. We'll get into this. Next is unsupervised learning. Unsupervised learning, we don't even give the output. Okay? We don't even give the output. We just give the input. Okay? We only give the input and we tell it basically understand something interesting about this input. Okay? Now for example, let's say I take some data from students at Royal College. Okay? Listen. Let's say I get some data from students at Royal College and I give them to this model, AI model, and I tell, buddy, tell me something interesting about this data. It will look at this data and see, okay, now these kids have an admission number which looks the same, 4, 5 something. Some kids have number 4 numbers but looks the same. And these kids all live around the same area. These kids are probably going to the same classes. Maybe these kids are from the same school. You can come to a conclusion like that, right? Got it? තේරුණාද? ඒ කියන්නේ නිකන් ඔයාලගේ data ටිකක් මම දුන්නාම ඒ ටික දිහා බලලා නිකන් ඒ ටික දිහා බලලාට හිතන්න පුළුවන් ඔයාලා එක ඉස්කෝලේක වගේ නේද කියලා. right? ඔයාලගේ ඔක්කොම විස්තර ටික ඔක්කොම ටික ඔයාගේ නම ගම ඔක්කොම ටිකත් එක්ක ඔයාලගේ කට්ටියගේම සෙට් එක දුන්නාම ඒ අයකට හිතන්න පුළුවන් මේ ටික බලලා මේ කට්ටිය එක ඉස්කෝලේක වගේ කියලා. මම එයාට කියන්න ඕනේ නැහැ මොකුත්. ඔයාලට හිතා ගන්න පුළුවන් මේ වගේ නිකන් relationship එකක් තියෙනවා කියලා තන. අන්න එක තමයි unsupervised learning කියන්නේ, right? So one of the things it's used for is grouping news articles. Have you seen when you search on YouTube? Have you searched on YouTube? You have searched on YouTube? No? Have you searched on Google? So you know how those articles, those videos are classified? Don't access Malay. Okay? So you know, like this is the algorithm behind that. Okay? it's given all the data about the videos and it learns, okay, these are probably about the same topic. Okay, then I should categorize them together. So if when someone asks for one, I'll give the rest as well. Maybe you like this. Got it? And it's even used in social media. Who are you on social? Who are the guys on social media? Instagram, Facebook. Okay. So you know you get recommendations, right, from friends and stuff. So basically it identifies maybe you guys are from the same school. Maybe you guys are from the same place.
When we watch like Instagram or the same topics like food topics,
Yeah.
it shows the same videos like
Yeah.
suggest food topics.
Good.
We already have access to one way.
So I'm talking about recommendations from people. Okay, like accounts as friends, recommending you as friends, like, you know, you get like, okay, you might know this person. Have you gotten some stuff like that? So it basically classifies, okay, you guys are quite similar, maybe you guys know each other. Okay, it identifies stuff like that. Okay, clear? Any questions? Good, right? තේරුණානේ? සුපර්වයිස් කියන්නේ ඉන්පුට් එක අවුට්පුට් එක දෙකම දෙනවා. අන්සුපර්වයිස්ඩ් එකේ අවුට්පුට් එක දෙන්නෙත් නෑ, ඉන්පුට් එක විතරක් දීලා මොකක් හරි හිතා ගන්න කියලා කියනවා මේ ටිකේ. හරි? ඉතින් reinforcements කිව්වම මොනවද මතක් වෙන්නේ? Okay. මේවද? reinforcements එනවා. as reinforcements කයි. ඒවද මතක් වෙන්නේ? Avengers Endgame එකේ එහෙම portals අරගෙන එනවා ඒවා. Okay, basically what reinforcement learning is, who has pets at home? Pets, dogs or cats? Who have tried training their dog or cat? Have you guys tried training your dog or cat? Cats train කරන්න බෑනේ. කියන දේ අහන්නේ නැහැ. Dogs. Have you guys tried training dogs? Okay. So how do you train dogs? You don't tell it like, okay, come here, this is how you sit, and do you sit down and show it? No, ne? When it does something good, you say good dog, right? Give him a treat, right? When your dog does something good, you tell him, oh, good dog, or you give him a treat. And if it does something bad, that's how you teach a pet, right? This is the same thing. Okay? Teaching computers like you teach your dog. සතුන්ට උගන්වනවා වගේ උගන්වන්න තියෙනවා. So basically we tell it to do stuff. හරිද? We openly tell it to do stuff, and if it does something good, we give it a reward. Okay? We reward him. Malli, if it does something bad, we give a penalty or a punishment. Okay? And it will then slowly and slowly learn to do more good things and less bad things. Okay? දැන් ඔයාලට උනත් කවුරු හරි ඇවිල්ලා ඔයා කරන සමහර වැඩවලට හොඳයි කියලා කියලා සමහර වැඩවලට නරකයි කියලා කිව්වොත් ඔයා ටික ටික හොඳ වැඩ ටික වැඩිපුර කරනවානේ. එයාට හොඳ වැඩ කරනකොට මොනවා හරි කන්න අරන් දෙනවා නම් නරක වැඩ කරනකොට ඔයා මේ පන්තියෙන් එළියට දානවා නම් Okay. So, and that's, have you guys played video games? So this is how your video games have like characters, or AI characters, right? This is how they are trained. Listen. This is how those AI characters are trained. We first put a very dumb AI character. Okay? Listen. Malay. So we put a very dumb AI character into the game. Okay? And then we tell it to do stuff. Okay? And if it does something good, we tell it it's good. And if it does something bad, we tell it it's bad. And then it slowly learn to do more and more good things. That means be more and more good at the game and be less and less bad at the game. Got it? Clear? Questions? Yes. It learned to balance. Now I have video for you.
Like that story of
Video. Oh, on balance. This is this is the Stanford autonomous helicopter. Do you know Stanford? Stanford is one of the best universities in the world. It's in US, okay? Palo Alto. So this is the autonomous helicopter. Look at this. There's a plot twist in the middle. Okay, now the helicopter is flying, right?
Flying. The audio is just
now the
about
plot twist is coming.
so that's not important. But we'll zoom out the video. So you can use
How's
the
that? That's an AI learning to fly.
The
So it can do. Nobody can do. It's very hard for a human pilot to do that. But when you teach AIs through reinforcement learning, they can do stuff like this. Have you have you guys seen the dog Spot, that yellow color Spot dog from Boston Dynamics? They do like flips and jumps and stuff. This is how they are trained. They are trained like this, okay? Reinforcement learning. They are this now. Listen. Now, when you are training the helicopter to fly, you don't know how to fly. You are not a pilot. The helicopter, so it will fall down. That helicopter. It will do that. It will do something else. It will fall down again. You take bad helicopter. And once it does something good, you take good helicopter. And you do bad. Okay. Linear regression. So okay, වචන දෙකක් නේ. Linear regression. එක වචනයක් කලින් කියන එක. we one word before. මොකක්ද කියන කලින්? regression කිව්වේ මොකක්ද කියලා අපි? මොකටද regression පාවිච්චි කරනවා කියන්නේ? regression පාවිච්චි කරේ we use in supervised learning, right? We have two types of supervised learning. Basic supervised learning you learned on the first day. Regression and classification. So classification is categorized as regression is patterns. That okay. So regression means predicting what's next trend. Okay. Others also, if you want, do that and say like that. What is linear means? Linear line. What is it? It sounds like line, right? Yeah, it's about line. Line. What's a line? What's a straight line?
straight line is the line that's straight.
Okay. So this is basically now regression. I told you it's used in stock market. You listen, right? Like this. But that's not linear. Got it? That is regression, but that is not linear regression. Linear regression means the pattern should be straight line. Regression means understanding a pattern like that, a series, like number pattern, odd number pattern, even number pattern, triangular numbers, stock market pattern, something like that, a pattern something, and predict what do next. Basically, you show the model the first three numbers and ask the next odd number, right? Got it? Okay. Now let's play a game. Yeah, once again. Before that. It's fine. Right. Listen. I'll give it. Right. Okay. So do you guys know this straight line? What is this? What is? That's a number line, right? Malik, grade 6 people have learned about negative numbers. Good. Number line, right? Okay. Now what happens if I do this? I put a number line like this, up, and I put another number line here. 0. Have you guys learned about Cartesian planes? Cartesian planes? No. Okay. So this is basically, listen, this is basically two number lines. Okay. Here you can mark points like this. Now the number line you can mark points only on the number line, but here you can mark points here and here and here. Okay. Yeah. Okay. So this is basically called now this number line you can move only this way. So that's one move. But we call this one dimension. Okay, one dimension, 1D. Okay. Here you can move up and down and side by side. There's number line here as well. Vertical, 2 way. What is that called? 2 dimension. Okay. So this is a 2 dimensional representation of data. It's what we usually use to do graphs. Okay. Right. This is a graph. This is a graph like that. Okay. Can you see there are points? There are so many points. So many points. Now I want to play a game. The game is this set of points represent a certain shape, and not all points are correct. Okay. These points are general. Now let's you guys you guys play in the Intel and you organize a running game. Okay. Now you guys don't have stopwatch with you. Most of you guys don't. So you guys just count 1, 2, 3, 4 and count the time the people take sometimes. So it doesn't usually end very accurate, right? It ends around the value, but it's not that accurate, right? So this is something like that, okay? It's not the best, but it's kind of okay. Can you recognize a shape here? Shall we see? It's like a line. It's a bit-like line. Now if someone tells you to draw a simple line, okay? Simple that does justice to the points as much as possible. And that also does justice to as much points as possible. This would be the shape, right? It is generally okay, right? Kinda, right? Yeah. Yeah, cool. Okay, nice. Now these points, those are counting errors and stuff. Okay. Next one. What's this? It's a circle. But there are like so much, right? So many mistakes. Exactly. Okay. Next one. What's this? Hey. Like kind of butterfly, right? For example, butterfly effect. Have you guys heard butterfly effect? Yeah. Butterfly effect. So have you guys watched Jurassic Park? Not the new stupid thing, the 1993 original. Yeah. So the entire plot of that movie is around the butterfly effect. You can hear that guy in the black jacket talking about it. In India, he puts a water plate on someone's hand or can't see which. The entire of the movie is about the butterfly. You learn that when you watch it. Okay. That's the distribution of points. Okay. Now I'm going to tell you. Okay, I'm going to do another. It's a straight line. Okay. But there can be many straight lines. I want to look here. This one. That is one. Another one. What is you know the thing that you guys did now? What's called? Linear regression. This is linear regression. Okay? This is linear regression. You guys identify that up to this line and this line. But it is that's the best line. Yeah. Huh? No, it's not. Meban? Meban එහෙම වන්දන් AI එක ඔයා මේ පොයින්ට් උනා මේ ලයින් එක මේකේ අඳින්නේ. ඒක පහ කරන්න. යන්දලා Yeah. He's trying to make the areas of those squares as small as possible. See, he's adding the squares. It's a sum of squares now. See, he draws lines, makes squares, and like the squares become big when the line is too off. Right? See? No, now presentation code. No, only from thing. It will come back up.
Yeah. These things are in the line, then they come up.
Using is called IPyNB and IPython notebook. It's kind of like Python, right? But I can add notes like this. Is it working? We have to use the video this time.
No, it's fine. It's delayed by 2 minutes. Yeah, okay, you're going to. It's fine. It's delayed by 2 minutes. It's fine.
Right. Okay. Now you can see Python code here, right? But I have written some text here as well. Now, IPython notebook means I can write Python and I can write notes about it. Like short notes, like I can say, okay, this is this part does this and this part does that. So when I look at the code again, I know what I have done. And also, now you can see this code is written as blocks. Can you see? Now in usual Python, you have to run the whole code, ne? But here you can run block by block. So let's say now, it's basically the same, but now let's say, if I have an issue in this block, no, this block runs smoothly, okay? Say this block runs smoothly, and there's an issue in this block, I don't need to stop, run this block again. Now this code is fine, right? But the issue is in this code. But in usual Python, I had run the entire thing again. But in this one, I just don't need to run this again. It's already run. If there's an issue, I fix it here and I run this part only. It's so useful. Okay? Yeah.
How do you know that that one is okay?
We'll see. Now, first is අපි ඔයාලට කියන්න. We'll do a separate session on what IPython notebook is. Okay? Can you understand? No? It's fine. Sure. So now the first subtopic is import libraries. Libraries means pieces of code written by other people. Okay? Now, now let's say you want to make a milk tea. You have two options. One option is go to a cattle house, buy a cow, bring her home, milk the cow, heat the milk, clean it, filter it, then pour it into a jug, heat it again, put the stuff and get it ready. Second option is you buy bottled milk from the shop and then you make your tea. Now when we are doing machine learning like this, we don't have time to raise cows. Okay? So what we do is we go to the shop and buy the milk. Someone has already made the milk for us. We make the recipe. Okay? This is like that. So these are like pieces of code written by other people, like making cow's milk. We are not going to write them from the beginning. Okay, so this NumPy is something. What do you think NumPy does? NumPy, a Python package that handles numbers. Cool?
Yeah.
Get the idea? NumPy. Yeah. So matplotlib. What does that mean? Mat means probably math or something. Plot means graphs. Lib means library. So it's like to plot graphs like that. Like I showed you. So this is that. learn machine learning models, right? That's a machine learning library. And you can see linear regression here as well. We are bringing the linear regression guy. So we don't have to write that square algorithm and everything. It's already written. We are getting that from the shop, and like we are getting our stuff done. Yeah.
Oh yeah, sorry to interrupt. Can you understand binary?
No. Okay. Now you know how to run this? That's a run icon. Then click run. See, there's a green tick. That means that part is run. Okay. Now what are we going to do here? We are going to predict the Olympic lap times
Oh really?
of Olympic players
2026? Oh.
throughout the years. Okay. Now I have a sample data set here.
Why would anyone know that?
Now these are the data. Okay. These are the data throughout the years and the time it took for a 100-meter race. Okay. Now I'm going to run this, so it's going to create a data set. Now, when you are looking at code like this, don't be scared. You don't need to, for your age, you don't need to understand it line by line. Okay? You just have to look at this and think it's English with weird grammar. It's English with weird grammar. Can you make something out of this? It says the x-axis is year. Can you figure it out from this line? Can you understand it from this line? Dot x label year means like x-axis is year. Dot y label winning time means y-axis, up axis, that is going to be the running time. And the title, that's the topic of the graph. See? Can you see Mali? See?
Yeah.
Oopsie. See? Can you see a pattern here?
Yeah.
It looks like a line, right? A little bit of like line.
Yeah.
So, why is it like going down? Yeah, because when the years are getting more. Yeah, so this is the top speed for 100-meter race in every year. Okay, so in 1975 around it took more than 10 seconds, but in around 2009-10 it's around 9 point something, right?
Yeah.
See,
Wow.
what is the reason? Basically, you know, when the times get better, better training, better equipment, better shoes, better trainers, right? But there are problems, see? No, 1975 is way worse than 1970. And here, this is so worse.
1980s.
Okay, so one of these is Monday. Huh? Okay. What's on? Huh? People going? Yeah. Yeah. No. Yeah. Okay. So one of the reasons is in 1968. Listen. In 1968, the Olympics were held in the Mexico City. That's a so high up place. Okay, it's like so high up in the mountains. And you know what happens when the mountains are high? The altitude is higher, right? Yeah, and the air is less thick. The air is less thick. Yeah, when the air is less thick, there is less resistance to run. ඔයාලා වතුර ඇවිදලා තියනවාද පූල් එකක? ඇවිදින්න අමාරුයිනේ. දුවන්න බෑනේ. බිම දුවනවා වගේ. අන්න ඒ වගේ තමයි උඩට යන්න තව ලේසි වෙනවා දුවන්න. කුලං ඒ කියන්නේ එයා අඩු වෙනවා density එක. right? so එයාට මේ ටක් ගාලා දුවන්න පුළුවන්. ඒක තමයි 1968 වල මේක පාට නිකන් running time එක අඩු වෙලා තියෙන්නේ. එයාර කන්ද උඩ තිබ්බ හින්දා නිකන් කට්ටියට ඉක්මනට දුවන්න පුළුවන් වෙලා. එකත් මේ හරිය තමයි. line එක country මේ නිකන් අර exceptions, right? These are like kind of weird stuff time to time. But usually it should be like this. But due to weird reasons it happens like this. And මේක මොකද? එකපාරට අඩු වෙලා අන්තිම එක.
Ooh, that's a Usain Bolt.
That's Usain Bolt. Have you heard of Usain Bolt?
Yes, he's running like this. Usain Bolt.
Yeah, so he ran and even the pattern broke after he ran. Oh my god. And there were world wars at time to time that affected, and the track surfaces. සමහර වෙලාවට වතුර තියෙනවා, සමහර වෙලාවට හොඳට හදපු tracks තියෙනවා, සමහර වෙලාවට එච්චර හොඳට හදලා නැහැ. So yeah, so that's the reason. Okay. Now what we do is, what do you think this does? This line? Okay. So what do you think this does? Okay, Mali, you think this is plain English and tell me what this is. Think this line is I'm going to ask from everyone. Everyone has to be on alert. I'm going to ask from each and everyone. What do you think this does? This line. Model equals linear regression.
What the base?
That creates a linear regression model. Plain English.
Oh man.
Simplest explanation. Okay, shall we create a linear regression model?
Yeah.
See how easy it is?
Hey.
Done. See the green tick? Now we are going to train the model. We are going to give it our data. Okay? We are going to give it our data and let's see if it figures out the line. Now I showed you some extremities, right? එයා දැන් අර මේ මෙක්සිකෝ සිටි වල අර කඳු උඩ තිබ්බ ඔලිම්පික් එකයි උසේන් බෝල්ට් දීප එකයි එක පිස්සු වැටෙන්නේ නැතුව මේක හොයාගන්න පුළුවන් වෙයි කියලා හිතමු. හරි? මේකේ පැටර්න් එක අඳුර ගන්න පුළුවන් වෙයි කියලා හිතමු. අරව ගැන වැඩිපුර හිතන්නේ නැතුව. Without like getting confused over those weird stuff. හරි. දැන් මං කිව්වේ නැත්නම් ඕගොල්ලෝ දන්නෙත් නැහැ නේ එහෙම එකක් වුණා කියලා. ඉතින් මෙයා දැනගන්න විදියක් නැහැ නේ කොහොමද? So don't be too harsh. Let's see. Hurry. Model.fit means we are telling, okay, fit the line to those data. Got it? Model.fit means, now what is the model? See, model equals a linear regression model. So the model is a linear regression model. Okay. Now we are calling it by the name model. Okay. Why are you sitting on that? Sit on this. Yeah. Linear regression means fitting a line to data, fitting a straight line to data. Does everyone understand that linear regression is fitting a line to data? Good? All cool? Arabi, there were 3 lines and you told which one was the best, right? Yeah. Ara points කොටක් තියෙනකොට ඒ ටික ඔක්කොටම හරියන්න තනි කෙලින් ඉරක් හදා ගන්න එක. එයා කලේ අර ඕගොල්ලෝ කිව්වා ඉරි ගොඩක් ඇඳහම මේක තමයි හොඳ මිර කියලාත් ඕගොල්ලෝ කිව්වේ. අර මම පෙන්නුවේ අර කොටු ඇඳ අර ඒක ඉර හදා ගන්න විදිය. මේක තමයි කරන්නේ. See? Yeah. I'll tell you. We'll be needing them the next time, huh? Yeah. Okay, Mali. So from the beginning keyword, now these are the libraries. You heard what libraries are, and this is the data set. These are the data. So the years 1968 and these are the running times. And why are the years 4x4? Why are the years 4x4? Olympics happen every 4 years, ne? So this is the distribution of data. You heard why this is low and why this is high and why this is ne? Okay. Now this means create a linear regression model and name it as model. And from now on, when I say model, know that this is a linear regression model. That's what it is in Python. Okay, I'm going to call you as model. Okay. I'm creating a linear regression model and I'm going to name it as model because I can't tell linear regression model every time. Okay, I'm just going to call it model. So when I say, okay, model, just fit a straight line to these data. That's what we do, linear regression, right? Fit a straight line to data. So I say model fit years and the times. Okay, did that. So this is gives some data here as well. No need to worry about that too much. And now we are going to tell it, okay, model predict this, and we are going to draw a graph. And let's see what happens. Now I'm going to tell him, okay, I'm going to give you the real data, and I'm also going to give you, and I'm going to also tell you to show me what you expect it to be. Now, in the real data, it was so much all around the place then. Now the model expects a linear line, right? A line. Let's see what it does. See? Can you see? The blue ones are the original data. Okay? Red ones are what the model thinks it should be. The linear regression model thinks that this is the best straight line. Do you agree with it?
Yeah.
Good, right? Yeah. Can you see like little bit of blue under these red dots? This one? Can you see?
Yeah.
Can, right? This one and this one? Little bit of blue here. Can. That means the exact value in real life and what the model expects are exactly the same. The line is so good. Match these points perfect. I mean, that means the athletes ran or like so much according to the pattern. They were like, okay, I should match the pattern. I can't lose by a single millisecond. I have to run to the exact millisecond for the pattern. Yeah, good point. Yeah. But there's a small problem. Agan. If this line continues, by 2030, people are going to apparate from this corner and disapparate from this corner and apparate from the other corner from because this is going to hit zero.
I will probably be 0.5.
No. This is like, this is still 9 now. Maybe this is 9.7. It will go around and hit 0 one day, maybe. I don't know. Yeah. Okay. Now we are going to do one more interesting example. Who of you are planning to live in Sri Lanka?
What?
Who of you are planning to live your life in Sri Lanka?
I don't hate it.
So you need to buy a house, right?
Yes.
So we are going to predict what's going to happen to the house prices when you grow up. So we are going to find the price of your dream house. When you grow up. Not now, when you grow up, what's the price? Yeah. Let's see if it encourages or discourages you.
We are already getting roasted by the house price.
Okay. No, then you can understand how much of salary you need to get. Okay. Now the code is very much like the same. Okay, but there are now. What do you think this does? Import libraries. Does everyone understand what import libraries does? Okay. Now in the last one I said it's the same thing. Yeah, these are code written by other people. By the way, pandas is not from China. It's not from the giant pandas. Pandas is a way to read data sets. Basically, Excel. Do you know Excel?
Yeah.
Basically, this can read Excel. Okay.
Panda can read Excel.
The package, this library, yeah. Okay. Now, and these are NumPy. You already know, right? Don't you all know what NumPy is? We talked about it in the previous example. I told you like what are libraries? Libraries are pieces of code written by other people, right? That makes our life easier. So we don't need to raise a cow. Okay? We can buy the cow's milk straight away from the shop. So NumPy means a Python library. What do you think NumPy means? NumPy. Python package for numbers. Okay. Right. Now we are going to import them. Okay, cool. Other people's code is here. No, language එක මල්ලි ඕගොල්ලන්ට Python ඉගෙනගෙන එන්න වෙනවා. හරිද? Python ඉගෙනගෙන එන්න වෙනවා. අපි දාලා තියෙනවා ඔයගලන්ට courses වල links වගේක් ඒ ටික ඉගෙනගෙන එන්න. මොකද ඊළඟ සතියේ ඔයගලන්ට code කරන්න වෙනවා. ඊළඟ සතියේ ඔයගලන් මොඩල් එකක් හදන්න වෙනවා. ඊළඟ සතියේ තියෙන්නේ nuclear missiles වලින් මොකක් හරි බේර ගන්න scene එකක් තියෙනවා. Yes. Python වලින් තමයි හදන්න තියෙන්නේ. Hi. Now, listen. Now that is import libraries. Now this is for loading the data set, right? Now tell me, what are the fact now? The Olympic running times are mainly decided by the year. By the year it gets better. That's all. But a house, what affects the price of a house? Obviously, when the year goes around, it's affected. Okay, thanks. Now let's say in terms of the characteristics of the house, in my opinion, the floor size of the house matters. When the floor size of the house is large, yeah, the number of bedrooms, number of bathrooms, ACs, what else? Tamana? Tava? Yeah. So for now, Malli. Does anyone want to go out? You want others to hear this? Okay. So for now, I am going to consider the year, the size of the house, that means the floor size, how many square feet, how many perches, etc. Number of bedrooms, that's beds. Yeah. And the number of bathrooms. Okay. And the output is the price. Okay, we need the price of the house now. So we are going to show it. The input is the year, which year was this price taken from, the size of the house, the number of bedrooms and number of bathrooms. We are going to give him all those data, and we are going to ask him, show him the price. Then we are going to tell him, okay, fit a straight line and figure out a relationship. Okay, and then we are going to give him your dream house's characteristics, and we are going to see how it works. Okay. Now let's say I have a data set. Okay, now is it going to load? This is the price, LKR, this is the address, number of bathrooms, number of this is the land size, bedrooms, size of the house, yeah, and location, seller's name, seller's type, year, address, latitude, longitude, stuff. Okay. Yeah. So that's the data set. Okay, that's an Excel. That's why I need pandas to read that Excel. This is an Excel, huh? Can you see? Okay. So I need pandas to read that for me and get the data to Python. That's why I imported pandas. Okay. That's done. Now I'm going to remove empty rows. May see? Do you see empty rows here? Wait, let's see. There were some down there, but I don't think you can see them. The code, yeah. Not the data set. Code. No, this was from Daras. Not Daras. Ikman.lk or someplace, I think. Okay.
You copied it.
Yeah. So I'm going to basically tell him if there are any empty rows, please remove them because it's going to confuse the model. Okay. If you like give empty stuff. Now train tests it. What does that do? Okay, listen. Now let's say your maths teacher is going to make your paper. She is going to give you sums to practice. What happens if she gives the sums that she is going to give in the exam to you?
That'll be too easy.
Then you are going to memorize the answers. Okay. So what she does is she keeps a separate set for you to practice. She gives them in the class, and she has a separate set in her mind for the exam. Okay, she's not going to show those to you. Same way, if you say show all those data to the model, it's going to memorize them. Okay, and it's not going to predict, it's just going to tell them from the memory. It's not going to learn anything. Okay, it will learn sometimes, but we can't be sure. So what I'm going to do is, I'm going to make x train, x test, y train, y test. Train means training the model, practicing. We are going to make AIs here. Okay, but you need to understand what these do. Just look at it as plain English. Okay, so what this does is split the test, split the data set. So it puts some stuff for practice and some stuff for the exam. Okay, train means stuff that we are going to give the model to train. Test means the stuff we are going to give to the model to evaluate it, see if it works well, see if it has learned. ඔයාට එක්සෑම් එකක් දෙනවා වගේ අපි ටිකක් තියා ගන්නවා මෙයාට උගන්වන්න ටිකක් තියෙනවා එයාට එක්සෑම් එක දීලා බලන්න පුළුවන්ද කියලා හරිද ඔන්න ඒක තමයි කරන්නේ මේ ටෙස්ට් සයිස් කියන්නේ මේ see test size means test means an exam, right?
Yeah. Yes, maybe it can be something else.
Yeah. So test size means, so 1 we take 0.2, that means from 1 0.2 means 20%, right? 20% you keep for testing, other 80% you take to learn. Okay, that's what it's going to do. Did you understand it? Everybody got it? You are going to use this next time, huh? Now same as previous, we are going to do the linear regression model. Yeah. Huh? TensorLab'26, let's say, yeah. Python. Huh? Yeah, you have? Yeah. I will help next week. So, right. Now, the linear regression model, that's the same as before, right? You understand that, ne? Now, model.fit, what does model.fit do? Yeah, I told you previously. Yeah, I did. Man කිව්වේ නැත්නම් model.fit කියන්නේ මොකක්ද කියලා? කිව්වනේ? ඔයා කියන්නේ මොකක්ද කිව්වේ කියලා මම? Fit a straight line to data නේ? Remember? You can't continue like this, next time you have to code.
No, you didn't say that. Yeah, you did say that. You said linear.
Yeah, linear regression. Fit a straight line to data. Model.fit. See? I'm only giving the train stuff. I'm not giving the test stuff. I'm only showing the train stuff. But I'm going to train it on. See, I kept 80% of the data for that. I'm going to do that. Done. Now let's predict the price of your future house. Okay, Malli. The year. Which year will you buy a house? 2040. Can't afford it, damko. Are. Floor size. I think this is square meters. Make shape. Okay. Number of bedrooms. 10. My God. 8. 8 bedrooms, do? Huh? 8 bedrooms. Bathrooms? 4 bathrooms. Yeah. 330. Okay.
8 bathrooms because one room needs one bathroom.
Okay. He needs 8 bathrooms. Hurry. Want to balamu? Yeah. Okay. Price එක කීයද ආවේ? 8 89 million.
Oh no.
89,250,336 rupees.
Okay, that's good. That's good. That's good. 89, 8 crores.
එහෙනම් අපි බලමුද නිකන් 2050 වෙද්දී කර මොකක් වෙයිද කියලා. ගාන මතක තියාගන්න. මේ ටක් ගාලා ලියා ගන්න කවුරු හරි ගාන. ඔකල මොකද? ආ? පියා යන්නේ 3:30. පුරාම අපි මේක කරා. යන්න. මේ ඉන්නවා කියන්නේ. හරි. ඔන්න තමයි ඒක 2050 වලට දානවා. ඒ ගානමනේ. ප්‍රශ්නයක් තියෙනව නේද? There's a problem, right? එකම ගාන නේ අවුරුද්ද වෙනස් කළාට.
Why is that problem?
අපි බලමු මොකද්ද කියලා. හරි ඔන්න මම දැන් ටෙස්ට් කරනවා යාව. එයාට ඔන්න මම එයාට ටෙස්ට් data ටික දුන්නා. See? ටෙස්ට් data ටික දුන්නා. දීලා I'm going to evaluate it. But do you know what these values mean? The test R2 means, the test R2, this last value, it means how correct it is out of 1. 1 means entirely correct. Correct every time. It's 0.21. That means when it comes to 100, 20%. That means every 10 answers he gets 8 wrong. Good. That's bad, right?
That's not bad.
That's not good, right?
So how much did it?
Do you know what's the reason?
Why? This video training
One reason is all of these. Can you see this year column?
Yeah.
Everything is from 2021. So how is he supposed to understand when the year is increasing, the price is increasing? See?
I didn't notice.
The other is 330. Right? The other reason, you know the other reason? Is this if is a house with 5 bedrooms the same price in Colombo 7 and in Anuradhapura? There are places from Anuradhapura, Colombo, everywhere. We didn't tell the model about that.
The specific.
We only told him about the bathrooms, bedrooms and what?
Yeah.
And the floor size thing? Yeah. We didn't tell him about this thing. We should have told him, right?
Yeah.
Otherwise, how could he know? So you are, so yeah, so it's a language.
Download that app and you make like mini chatbots like that.
Yeah. We'll tell you later, okay? So listen. Now today your homework is you have to make this model correct. Okay? Learn Python. I'll tell you, I'll instruct you on the WhatsApp group, okay? You have to go home, learn about this model. You have to revise everything. You wrote that stuff down. Okay, you have to write it down in the lecture scribe as well. Not the no, the summary, what I told, okay? So you have to yeah, they'll show it today. So the thing is, you have to find out a way how to give the location. You know how to do that? Mage oluwata awe mehema ekak. Harida? We take Colombo 7 as the center and we measure the distance to every place in Sri Lanka from that. Colombo 7 වල ඉඳන් තියෙන දුර. සාමාන්‍ය Colombo 7 වල ඉඳන් තියෙන දුර වැඩි වෙද්දී house එකේ ගාන අඩු වෙනවා කියලා හිතන්න පුළුවන්ද? shape එක හිතත හැකිනේ. shape. Simply let's think like that. You try that at home. එහෙම එකකුත් දාලා බලන්න. Now you can understand this code නේ. Okay, you can use the same code නේ. You can use the same code and just extend it a little bit, right? Okay. Now we'll go back to the presentation. That's it for today, but we have something from last week, little bit, the entertainment session. Last week's entertainment session. Yeah. To fix the model to get the correct house price. I told you, you have to check the location of the house and everything for that. Huh? We'll tell you, man, later. Yeah. We'll give you the instructions on the group, Mal. Okay. Now, shall we finish with the last session? Feel that?
Yeah, you can have go later, but this Harriet is kind of tired, I guess.
Huh?
He's kind of tired, I guess.
Yeah, okay. Okay. So we'll quickly finish this. Now, may you guys, I told you how to remember each other's, I told you to remember each other's, what do you call, the talents. Now you have to form a team. This team will continue to do activities from next week onwards, and team will get marks. So find the best guys for the team. I'll give you 2 minutes quickly. We need to form 6 teams. Form 6 teams. Form 6 teams. Quickly, quickly. 6 teams. Okay, you have 30 seconds more. You have 30 seconds more. Team එකක් හදන්න. පුටු අරන් යන්න එපා පුටු තියලා. I'll tell you. You have to make a team. Make a team. Also, when you're recruiting for the team, I think you remember what each people said. So get a programmer, get a guy good in maths. Okay? Nice. Okay. Now it's time to watch some movies. Okay. Have you heard about Isaac Asimov? So, have you watched the movie called I, Robot? No. Okay, so he was the first guy who wrote about robots in literature. Okay, he told. Talk about it. We'll watch one. Okay, not a whole movie. Right? Just a small clip. If you like, you can. These are for the first session, nah? Extend your first session stripes with this if you want. So this was written in 1950s. Shh. Listen. 1950s. This is mostly about, now there are different kinds of AI in movies, ne? So this is about ethical AI. Ethical like good AI. So now he introduced laws of robotics. He told that every you remember the AIs that are operating on rules we talked about last week? So he talked about. Okay. So he wrote 3 laws, and he questioned whether intelligence can be modeled through a circle of these 3 laws. Mali, listen. These are the 3 laws of robotics. Here's Isaac Asimov. It says, a robot may not injure a human being or through an action allow a human being to come to harm. So these 3 laws means, the first law means a robot can't basically hurt a human. Second law means a robot cannot do any action that makes a human go into harm. Okay? Okay. You can stay in your place if you want. Stay in your place if you want. So, for example, let's say the second law states that a robot must obey everything a human says. Okay? The first law says that a robot cannot harm a human being or cannot allow a human being into coming into harm. Like if it sees a human being trying to jump off a cliff, it has to go and save him. Number 2 is it has to do everything a human being says, but it can't disobey the first law. That means if a human being says go and kill another person, it can't do it. Okay? Because it completes the first law. By the first law, the robot can't kill a human. Okay. And the third law is a robot may try to protect himself, but it can't disobey the other two laws. Okay? Have you watched this movie?
Yeah, I heard the Space Odyssey. I read the Odyssey.
Okay. So it talks about a supercomputer called HAL 9000. This is dangerous AI. Yeah? The previous was ethical AI. It had 3 laws. It obeyed those 3 laws, right? If it obeyed those 3 laws, it can't harm a human. You saw it. It can't anyways violate the first law. What did the first law mean? Second law?
It cannot obey the
Oh.
law.
Third law?
As long as it is not harming.
Third law?
It needs to protect its own existence and unless it comes in conflict
Yeah.
with the person.
So basically it can't harm a human. Okay. So okay. So and so this is a space mission where they send a supercomputer called HAL 9000. Okay, I'll show you. So this computer is given instructions to carry out the mission perfectly, and it tries to do it too perfect and it kills the humans. It's a very nice movie. It's the one of the first conflicts of man versus machine conflicts, man versus AI conflicts. This is one of the first times it was introduced. Okay, so this movie inspired another movie that you guys very well know. Look at the next slide. I have put some side-by-side comparisons of shots from those 2 movies. See, don't they look the same? Don't these look the same? Don't these 2 shots look the same? Don't these 2 shots look the same? Don't these 2 shots look the same? Yeah, that's Interstellar, and that one is 2001 Space Odyssey on your right hand side. So see, that movie inspired Interstellar. Okay? So it's a nice movie, go home and watch it. 2001 A Space Odyssey. You can, I think it's on I don't know if it's on Netflix, you can buy it on Google Movies, I think. Have you heard of Terminator? This is the baddest AI, yeah? It's about it's called a Skynet is an automated military defense network. Now they take it to make sure there are no casualties in the military, and it works very well. And then they get scared and they try to shut the network down. And the AI thinks, okay, they are going to kill me, I'm going to kill them. Okay? And it takes over and launches nukes. You know what it does? It launches all the United States nuclear missiles at Russia. So Russia thinks US is attacking us, and Russia launches nuclear missiles to America. Both countries destroy, nuclear war, and it makes robots like these to hunt humans. They make it shows how catastrophic AI could be if something goes wrong. Shows how catastrophic it could be. So now these are called T800s. They make T600s. These T800s, they grow a human skin on. This had the original movie in 1980s. And there are 6 movies, I think, Terminator series. Yeah. I don't think it's on Netflix, Mali. It's so old. Yeah. I think he has that. He'll get it. Okay, later after the session. So even today, this is the picture from Terminator that they used to show when AI is taking over, it's going to kill you. This is a killer machine. It grows a human skin on, and it looks like a human. And then it goes and it's programmed to kill specific humans. What happens is, listen. What happens is now, in the future, after the war, after the nuclear thing, the machines try to kill the remaining humans through these killing machines, and then the humans get together and they fight. And the machines learn that these humans have a fighter, the leader, and the machines send a Terminator back in time to kill that mother of that future leader before the future leader is born.
Oh man, that's so disgusting.
Yeah. Okay. Have you heard of this?
Yes, that's my brother.
have you guys? This is a 1982. This featured from 1982 to 1986. Okay, this is about an AI companion. Okay, it's 19 Industries 2000. It's a supercar. It doesn't get damaged by anything, and it was one of the first depictions of self-driving. In my life, this is one of the inspirations that got me into AI. Yeah. So you guys might have an inspiration like that. Last two slides.
5 minutes of podcast.
Okay, it's ending now. No, we are going to watch a small clip and the session's going to end next. Huh? So one small clip from Knight Rider. Do you want to watch it?
Of course, if you can start AI, of course.
Okay.
No resemblance between that car and your own. It's purely superficial. What are you talking about?
Okay.
Devin, that's my car. I left it out.
Wait, we'll put audio from there. Wait.
There's no output on this.
It's not. Okay. Can we put?
There's no output.
No, ne. We'll put for this for now. Ne. If they can hear, ne.
Yeah.
Okay. Shoo. Shh. Otherwise, we won't be able to hear.
No resemblance between that car and your
So
own.
this
It's
is when
purely
this
superficial. What are you talking
Michael is hunted by criminals, and they do a plastic surgery on him and give him a new identity, and they are renovating his car into a new thing. Okay, see.
No resemblance between that car and your own. It's purely superficial.
You can hear
What are
it.
you talking about? Devin, that's my car. I left it out in the desert. No, it may look like your car, but in actuality, this vehicle is probably the most expensive car in the world. Come on, this is my car. It's just a new paint job. Feels like baby skin. Boy, those guys did a nice job. There's not a ripple on it. Like a mirror. It's not paint. It's a finish bonded into the molecular structure of a new substance. You mean the metal? It's not metal. And it's not fiberglass, excuse me. Yeah. Strike the surface as hard as you can. Come on, Devin, I'm not going to hit my car. It's beautiful. There's not a mark on it. How did you do that? Don't just stand there with your mouth open. Get in the car. I'll show you. Welcome aboard the Knight 2000. Thank you. What's all this? Looks like Darth Vader's bathroom. It is a one-of-a-kind car, Mr. Long. It is the fastest, safest, strongest car in the world. It is also completely fuel efficient and is operated entirely by microprocessors, which make it virtually impossible for it to be involved in any kind of mishap or collision. Unless, of course, specifically so ordered by its pilot. Pilot? Don't tell me this thing flies. No, but it thinks. It thinks. My car thinks. We like to think of it as our car. Now, in order to motivate it forward, I recognize the more rudimentary controls such as the accelerator, Devin. I do know how to drive. I would have preferred you to have let me open the door first. However, as you see, no harm has come to the car. You also told me this machine couldn't have a collision. Not if the system is operable. And to do that, you have to switch it on first. Like that. Now you're telling me I can't hit anything. Trust me. I'll never trust anybody again. I'm warning you, Devin. I'm gonna put this thing to the test. Be my guest. I don't believe this. Playing chicken with a 10-pound semi. now? Yes, it's marvelous, isn't it? I hate it. I like to make my own decisions. Oh, the microprocessor deduced that you were acting contrary to your best interests. It had two choices. Either to slow down or to maneuver around the obstacle. So why didn't this thing slow down instead of driving around the truck? It would have been a lot safer. Well, why? Come on, I find a flaw in their perfect machine here? No flaw, I assure you. It's just that... Well, just what? Well, it was showing off for you. What? Well, you're telling me that this car can just take off, go for gas or a car wash just like that, huh? Mm-hmm. That would be terrific if I happened to be working under it. It wouldn't harm you, I assure you. Its primary function is the preservation of human life. Your life. By me, you mean anybody driving this? No. I mean you, specifically. You, Michael Arthur Long.
So basically, molecular structure එක හදලා තියෙන පුත් යකුවට වෙඩි තිබ්බට පුත් වෙන්නේ නැහැ.